So for this first experiment, it is just a battery, switch, resistor, and LED connected with some wires. So the first resistor is a 10 kilo ohm resistor, and we're switching that out with a 1 kilo ohm resistor. So it should be a lot brighter than the first one. And then we are switching it out with a 100 kilo ohm resistor. So the LED should be a lot dimmer this time. So the second experiment is very similar to the first one, except we have the variable resistor. So turning it to the right will make the resistance increase, and to the left it'll decrease. So this part we're also switching the wire, so that instead, this time as we move the dial from left to right, the LED will go brighter instead of dimmer. So now we're going to move the resistor so that the variable resistor won't have any effect as we turn the dial either way. As you can see, nothing is happening here. So experiment 3 demonstrates resistors in series. So we have a 3.3 kilo ohm resistor and a 100 kilo ohm resistor. And we are going to replace the 100 kilo ohm resistor with a 10 kilo ohm resistor. So it should be a lot brighter this time. And then we are going to replace that same resistor with a 1 kilo ohm resistor. Experiment 4 demonstrates parallel resistance, and we have a 100 kilo ohm and 3.3 kilo ohm resistor. And then we're going to replace the 100 kilo ohm resistor with a 10 kilo ohm resistor, and we will see that this doesn't really have much of a difference. Now if we change that resistor to a 1 kilo ohm resistor, the LED should be a lot brighter now. Experiment 5 uses basically the same circuit, except we have two LEDs in parallel this time. So the LEDs will only change with their respective resistors. And if we switch out the 100 kilo ohm resistor with a different one, I'm switching out with a 1 kilo ohm resistor, we will see that only the left LED will change and the right one will not. And then I'm going to demonstrate that again, but with a 10 kilo ohm resistor. Now in experiment 6, we add a variable resistor so that it is parallel with the other one, and turning the dial will change the brightness of the LEDs. So if we turn the dial from left to right, we will see that the right LED will be brighter than the left one, and vice versa. For experiment 7, we have two resistors in series and two resistors in parallel. And then I'm going to connect two wires and leave them as loose for now because we are going to put that into the water. So as they're put into the water, the LED will be lit up and it will be pretty bright. For the second part, we're adding more water to the cup. And doing this should make the LED light up brighter than it was the first time because of the amount of water that is in the cup. And it might be a little hard to tell because of the camera, but it is pretty bright. Now we're going to add salt to the water and stir it. And by doing this, we are decreasing the resistance that the water has, so the LED should be brighter. And again, it might be a bit hard to tell with the camera, but it is pretty bright. Now for experiment 8, we have what is called a slow light bulb because we have added a capacitor to our circuit. And here I'm going to close the switch a couple times just to show how the capacitor charges, and then as the switch opens, it will discharge. So the LED will light up and then slowly turn off. Now I'm switching the resistor to a 1 kilo ohm resistor, and basically this should make the charge and discharge time faster. Now for experiment 9, we have capacitors in series, and the larger capacitor will basically take over and make it so that the charge and discharge time are even faster. Now for experiment 10, we have two capacitors in parallel, and because they're in parallel, the capacitance will be larger than it was in series, so charge and discharge times will be increased. Now in experiment 11, we have the positive side of the battery unconnected, a loose wire, and an unconnected resistor. So if we touch that part of the battery to the loose wire, we're charging the capacitor, and then when we touch that loose wire to the unconnected resistor, the LED will light up. This is because the capacitor is discharging. Now I'm going to demonstrate that one more time. Now in experiment 12, we introduce a diode so that the current can only flow in one direction. So here it's the right way, so the LED is lighting up. Now we're going to take it out and put it in the opposite way. So now when we press the switch, nothing is happening because the current cannot flow. Now if we put it back to the way it was originally, but we change the LED so that it is the opposite way, it will not light up. After experiment 13, we have the positive side of the battery unconnected and two loose wires along with a capacitor. So basically what we're doing here is we're connecting the positive side of the battery to one of the loose wires so that only one LED lights up, and then we're connecting the other loose wire to the loose wire connected on the negative side of the breadboard so that the other LED will light up this time. And that's it.